Okay, so hopefully this will give you a little bit of a hand if you're having trouble with the similar triangles at Year 9. The worded questions are posing a little bit of an issue for some of us, so let's hope this sorts you out. So here we go. On a bright sunny day, the shadow cast by a flagpole is 12 meters long. The first thing we want to do is draw the flagpole. So you should use a ruler. Wow, that's not very straight on my behalf. And there we go. So we've got the shadow down here is 12 meters. And what else we know? At the same time, so that's really important that at the same time, because that means the angles will be the same, the shadow cast by a 30 centimeter ruler. So up here, and obviously it's not to scale, 30 centimeter ruler and 45 centimeter shadow. So we've got the shadow again going along here. First thing we'll do is make sure that we're working in the same unit. So instead of writing 30 centimeters, I'm going straight to 0.3 meters, and down here 0.45 meters. Find the height of the flagpole, put your unknown there. So always put all your information in. We know that these are similar triangles because this angle here that the sun makes with the shadow, because it's at the same time, it's going to be the same angle. If it wasn't at the same time, then the angles will be slightly different. Similar triangles don't exist. My tip is start where your unknown is. So I look at this triangle and I'm going to start with, we've got x over 12 equals, now x's corresponding side here, it's pretty easy to see that it has to be 0.3. So we'll pop the 0.3 there, all over 0.45. Your job is to try and get x by itself. It's being divided by 12. And you all know that the opposite of divide by 12 is times. Instead of going straight to your calculator, make sure that you write everything down. Really important to use the nice notation to keep everything visible and that your working out is nice and clear. And now go to your calculator and we get an answer of 8 meters. And for any of you who are checking the back of the book and they might have something different, 800 centimeters, whatever, just make sure you do check the same units are being used. Okay, so hopefully that made a little bit of sense. Try the next question, and if you get, so pause the video, but if you get stuck, then go and have a look at the solution. Okay, on to the next one. It is known that a boulder B, so we've got a lot of words here, but the best bit is we've got our diagram, and let's see how we can go with that. Let's just use a different color now. We'll go red. So a boulder B is 50 paces from the tree T. So we'll put 50 over here. I hope you're not colorblind with the red on the green there. From a point X directly opposite T, Harry the hiker walks 10 paces directly away from the bank to point Y. So he's walked directly away. We've got 10 over here. He turns right and walks to point Z, which is in line with BX. Okay. Explain why triangles TXB, so this triangle here, and YXZ are similar. Well, we could say, if we're writing this down nicely, we would say that angle, change back. We're going to say that angle, this angle here, which we'll call BTX, that equals 90 degrees, which is the same as angle XYZ. And why did we know this? Because it was given to us in the question. We also know that this angle here is the same as this angle here because they're vertically opposite. So again, we can say that angle BXT equals angle YXZ. You could write vertically opposite if you like. I just like to write VO. Keep it simple. So therefore our triangles are similar as they are equiangular. Okay, we know if Y and Z are 20 meters apart. So again, every time you get a bit of information, pop that on your diagram. So YZ is 20 meters apart. Calculate the width of the canal. So we want this one here. This is the hardest bit of the whole thing, and once you've got this under control, the rest just flows. It's getting the ratio correct. So again, go to one of the triangles that has an unknown in it. So I go to this one and I start with the x. I'm going to say that's going to be x over 50. So now I need x's corresponding length on this side. So I simply go, well, x is right angle to dot. So right angle to dot here is 10. And so I know that 10 is its corresponding side. Now 50 is right angle to blank, nothing there. And right angle to blank is 20. And that is the correct ratio. And therefore, to get rid of this divide by 50, we'll times. So that's 10 over 20 times 50. So that will give us 1/2. So 25 meters. Bang, done. I hope that's the same answer you got. So again, I'm about to go on to the next question, so please pause the video and don't have a look at it until you've had a go yourself. Okay, we've got a 3.5 meter ladder. Okay, we can see that these are similar triangles because we've got, this is vertical, so 90 degrees, 90 degrees, and we've got a common angle that's shared there. Now the first thing I will do is draw these triangles separately, and I don't waste too much time on getting the exact measurements or anything like that. It's just a sketch to help me. But remember, draw in the angle that you, the angles that you know. And now we put in our information. So for the little triangle here, we know that that's x. We know that this is 2.4. And on the big triangle, we've got 3.5 and 2.9. Go excellent, away we go. Start with the triangle that we know. We go x over 2.5, and now we want x's corresponding length over here. Now x is dot to right angle. Dot to right angle, we don't know. So don't just go, oh, I'll just pick random any of the two values that I have here. It has to be the corresponding length. Now it doesn't mean that you can go no further. Lucky for us, this is a right angle. So I'm going to call this length y now. And good old Pythagoras, we know that he says y squared plus 2.9 squared equals 3.5 squared. So if you remember, it's the two right angles that make up, the two lengths, sorry, that make up the right angle. You square them, add them together, and that will equal the hypotenuse squared. Now we want to get y by itself, so we keep the y squared, and we say to get rid of a plus 2.9 squared, we're going to subtract. And to get rid of the squared, I'm going to square root. We can go to the calculator, we'll just check that out. So 3.5 squared minus 2.9 squared. I like to use exact values, but your calculator will probably give you a decimal. So when I type that into my calculator, I get this groovy exact answer, like so, which rounds off to be 1.96. Now, whenever you use a rounded answer in a further calculation, you're going to be less accurate, but that's okay. We're just getting the hang of the ratios. So we know that this length now is 1.96. So that will be x's corresponding length here, and 2.4 its corresponding. So from right angle to the blank, right angle to blank here is 2.9. So you're pretty used to this now, I think. To get rid of this divide by 2.4, we're going to times. And make sure you write all of your steps. Keep it nice and neat and orderly. Looks like you're doing heaps of work. So 1.96 divided by 2.9 times 2.4. And we end up with, oh, I think I've done a bit of a whoopsie there, so check that, 1.96 divided by 2.9, because I ended up with an answer of 34 point something. That didn't seem realistic. So always check that you've got a reasonable answer. So we've ended up with 1.26 meters, which seems to be more in line with the question rather than 34.7. Okay, so always check your work. Hopefully this is starting to sink in a little bit more with you. All right, so let's now again pause the video, have a go at the next question without looking at what I'm doing, and see how you go. Okay, onwards and upwards. We've got two surveyors. We read very carefully. One stands 5 meters away. Yep, we've got that. Holding a 3 meter stick vertically. Well, how come they've got 2.4? We read on. The surveyor finds a line of sight. So the vertical stick, it cuts it at 2.4. So this is a red herring, this 3 meters. It's not actually involved in the question. So just be wary. That's a bit sneaky of them. The distance from the stick to the top of a hill is 1,500 meters. How high, correct to the nearest meter, is the estimate of the hill? So we want this one here. So again, I would be saying draw these triangles separately. We've got 5, we've got 2.4, then we've got our big triangle where this is the height of the hill that we want. And what else do we know? Well, we actually don't know this whole distance, do we? We know that part of it is 1,500, but we don't know this little bit here, which is that. Now that, correct me if I'm wrong, but that is this hypotenuse here. So what we can do is once again use good old Pythagoras to help us find this length. So that length there will be this bit over here. Don't know if you could see that. So we'll just use a slightly different color so you can see that this bit here is actually going to be that length. So imagine if we found that out and it was 10, we just added on to this, so that would be 1,510 meters. So should remember Pythagoras from the question we just did. It's the two lengths that make up the right angle. We square them together, so that's going to be 5 squared plus 2.4 squared equals y squared, and therefore y is the square root of 5 squared plus 2.4 squared. Are we happy with that? So we can go to our calculator and we'll work out 5 squared plus 2.4 squared, all square rooted, and my calculator gives me an exact answer. That is the square root of 769 all over root 5. And if we were to round that off, 5.546. Now again, if we use this, I'm going to be using this twice. So bear with me and just see if you can follow along. I'm going to use this exact answer here to make life easier for us. So, well, not easier, more accurate. Remember, your calculator will be doing all the work, not you. So this length now is 769 all square rooted divided by 5. That's this length, which means this big length here is 1,500 plus that length over there, 769 all over, or square root all over divided by 5. Okay, so go to the triangle that's got your unknown in it, and it's going to be x, and we're going to divide it by this ugly number here. Now remember, you don't have to work that out, your calculator is working it out. The hardest part for you is going to be typing it into your calculator, which I think all of you can master quite easily. So x over that length equals, now x, we've got, this is the common angle, naughty me, I didn't put my angles in at the beginning, which I said you must always do. So we've got x over this length here. What's its corresponding side on the other triangle? So those two are corresponding sides, and then we've got this length here will be corresponding to this one here. Okay, so I've got x over this will equal 2.4 over. Again, it looks ugly, you've got a fraction on a fraction, but hey, make those calculators work. And we are going to say, to get rid of our x divided by all of this, it will be times. Now if this is bamboozling you, just replace this ugly number with 5.546 if you can't cope. But our answer here will be beautiful, and people looking at your work will go, wow, that looks crazy hard. And you should know it's not actually that bad. Okay, so we've got 1,500 plus root 769 all over 5, and that looks really impressive, but again, your calculator would do all the work. So pop that in, 2.4 over square root 769 over 5 times, and the brackets are important here, because if you don't have the brackets, you will only times this answer by 1,500, and you actually want to times it by 1,500 plus this. So make sure that you use brackets, please. You might try typing that into your calculator a couple of times before you get, oops, sorry about that, before you get the right answer. Good practice. Okie dokes. So what we've got is the estimate of the mountain is 651.5 meters. So that's it for that little section that we were doing. I hope that helped and that you got most of those ones. The last two were a little bit tricky, needing to use Pythag, but hopefully you conquered.